In this section, using the TI-83, the most important things that you'll need to be able to calculate are the range of a set of data, standard deviation, and then the variance. Luckily, this is all found in pretty much the same place regardless. So I have an example problem here for us to work, and we'll work through this together, finding those values and then showing you in a minute weighted statistics, which is also included in this lesson. So the nice thing is we're working with a list of data, and at this point you should be proficient using lists in your calculator. If not, you should go back to previous videos and learn how to use lists. So those of you who are proficient, go ahead and follow along. If you hit the stat key and then enter, that'll take you into the list editor. And of course, if you have any data in a list already, you'll want to highlight the name of the list, press clear, and then enter. Now, at this point, you need to put data in from the example problem. So I'll just start entering this data into my list, one item at a time. Just give me a moment and I'll take care of that. And I hope you don't mind, I just went ahead and paused the video and entered the rest of them, just because I'm certain that you could do that on your own, okay? Now, once your data is in, the cool thing about range, standard deviation, and variance is that we don't really need to learn anything new. It's all contained under one-var stats, which we learned in detail in the last section. So we just need to run one-var stats. So quit out of the list editor, press stat, slide over to calc. The very first item is one-var stats. And then it's optional, but I think it's a good idea to tell it where your data is at this point. So it will come up with all the different statistics that we generally need for a single variable. So the mean, median, mode. So, well, it doesn't do the mode, obviously, but different statistics. Now, in this case, we just really want to learn how to do the range, standard deviation, and variance. So let's start with the standard deviation. So the standard deviation is pretty straightforward. It shows up right here on the output screen. So we have SX, which is a sample standard deviation, sigma X, which is a population standard deviation. You should be told whether your data represents a sample or population in the problem, and if not, just assume a sample. All right, and then choose the standard deviation which applies to your case. So in this case, 10.5 to 1 decimal as it requests. Now, the variance is also pretty straightforward. It's literally just the square of the standard deviation. So whatever value you find for the standard deviation, just take that number. So for instance, in this case, you could just say 10.5. You could do the rounded value and then square it. But the squaring of decimal values is pretty sensitive to how many decimals you choose. So it's probably a good idea in practice just to use as many decimals as you can. So that way you get the most accurate answer. But you're just squaring the standard deviation is all. Another way of doing that, if you go into the VARs menu, the calculator actually stores all the calculations it does. And sometimes it's hard to find, but we're doing statistics. And these are all the variables that show up after doing basically one-var stats. So you could get SX right here, and that's another way of referencing SX, the standard deviation that is, using as many decimal places as the calculator holds. But you can also just copy the number. It doesn't really make a whole lot of difference. Now, the range, let's go back into one-var stats, and I'll show you how to get the range. So on the next page of output, if you scroll down a bit, you'll see min X, Q1, median, Q3, and max X. So whereas it doesn't tell you what the range is particularly, it does give you the minimum and maximum value, and you can just take those two numbers and subtract them and get the range that way. So 39 would be the range in this set. And next up, let's take a look at how we can do weighted statistics on the calculator. Now, this is going to be no different from the example we did in section 1.5. So just kind of follow along. I've got an example problem here. It's just looks like ages of weights of dogs. It doesn't really matter the context. How we go about doing the calculation is really the only thing that makes a difference. All right, so if I go back into my list editor to start entering new data, I need to clear out the first list that I was using. And I have grouped data here. I have a set of class ranges, which I need to convert into midpoints, and that will go into L1. And then I have frequencies, which will go into L2. So let's start with the midpoints. So if I take 8 plus 23 divided by 2, and remember, it will do this calculation and just enter the result, which is very handy so that you don't have to actually go off to the side and make the calculation and then enter the result there. So, and you can do these for each one. If you'll notice here, the difference between these two values, what is it, 16? Let me see real quick. Yeah, it's 16. So that means my class width is 16. So if I instead just continually add 16, so 31.5 plus 16, that would give me the next midpoint. And then 47.5 plus 16 would give me the next midpoint, and so forth. So 63.5 plus 16 would be 79.5. And if you want to check and make sure you haven't added anything improperly, if you take the midpoint of the last class, you can compare it to what you came up with. And if you added improperly along the way, this won't match up. So that's kind of a nice little check there. All right, and then our frequencies, if I start entering the frequencies here, there we go. That's all we would need to do there. Now, in order to get the weighted statistics, I quit out of the list editor, and I still use OneVerstats. Only thing you have to remember for weighted statistics is that what we need to tell the calculator is that we're using two lists. So we make sure to do the second and 1 to get L1, comma, second and 2 to get L2. And then when we press enter, it will do weighted statistics and tell us what we need to know that way. So let's see, in this case, we have ages of dogs at a veterinary. Okay, it's a sample, it says right here, this is a sample. And the only reason that matters is when I choose the standard deviation, I need to know if I need SX or sigma X. Since it's a sample, I use SX, so my answer here, say to 2 decimals, is 21.07. The mean, 57.28. And we're all set. Those would be the weighted statistics for this particular set of group data.